The Java Executor service is a thread pool to which you can submit tasks for concurrent execution. And if you look at the diagram here on the right, you can see we have a main thread here, and it submits a task to this thread pool here, this executor service. And then inside the executor service, we have two pool threads, which then will take these tasks and execute them. Here on the left, I have an example of how to create an executor service. As you can see up here, one of the ways in which you can create an executor service is by calling one of the factory methods of the executors class. There are more factory methods than this one here, new fixed thread pool, but this is one of them. This particular factory method creates an executor service with 10 threads pooled inside of it. Down here, the example submits 3 runnables to the thread pool, and finally the example shuts down the executor service, and that will shut down the executor service after it is done with all of these, with executing all of these tasks here. And there are more methods than the execute method here to submit tasks to the executor service, and I will get back to them later in this video. Let me just have a quick look here down here, or let us have a quick look here down here, and you can see that the tasks that the example is submitting to the executor service, they implement the Runnable interface, which is the same interface you would implement if you were to execute this task here within its own thread. Okay, so in this case, the example, the Runnable implementation here simply creates a message. It constructs a message from the name of the thread that is executing this task here. Thread.current.thread.getName results the name of the thread executing the task, and then it concatenates it with a colon and the message that is passed as parameter to this new Runnable method here, and then it simply prints out that message. Now let's try to run this example and see what it prints. As you can see, as we expect, it prints out pool 1 thread 3 here. That is the name of the thread executing task 3, and you can see task 3 is this task here. And you can see it's the same here. Thread 2 executes task 2, and thread 1 executes task 1. Now there's no guarantee about which thread a given task will be assigned to. So the fact that thread 1 is always getting task 1 has to do with the fact that the executor service has just been started up. So the sequence in which the tasks are assigned to the threads is going to be pretty much this sequence. But if it had been in the middle of execution, then thread 2 could have been finished with its previous task earlier and then gotten the next task before another thread. Okay, so there is no guarantee about which thread a given task will be assigned to. Let's just try to run it again, and you can see that the sequence here is also different now. Thread 1 finishes first, then thread 2 and thread 3 finish the task afterwards, and you can see the order changes. And the order changes because the scheduling of the threads internally in the executor service changes from run to run. Executor service is an interface, and that means that in order to use it, you must create an instance of a class that implements the executor service interface. Java has 2 built-in implementations of the executor service interface, and the first class here is ThreadPoolExecutor, and the second class is scheduled ThreadPoolExecutor. The main difference between these 2 implementations is that the ThreadPoolExecutor will attempt to execute the task you submit to it as quickly as it can, whereas with the scheduled ThreadPoolExecutor, you can schedule a task for execution at a specific time in the future. Now, I will not cover the scheduled ThreadPoolExecutor in this video. I will probably cover it in its own video sometime in the future. So I will focus mainly on the executor service and the ThreadPoolExecutor here and the ExecutorService interface. In fact, the schedule ThreadPoolExecutor implements the ExecutorService interface, but it actually implements an interface called scheduled ExecutorService, and this interface extends the ExecutorService interface. So that means that you can actually use a scheduled ExecutorService in the same way as an ExecutorService. So anyways, I will not get into more detail about the scheduled ExecutorService. The basic premise of these two classes are almost the same, except the scheduled ExecutorService allows you to schedule the task for execution in the future. In this concrete example, a ThreadPoolExecutor instance is created, which has a core pool size of 10, which means it starts out by having 10 threads, and that is like the base number of threads in the pool. And then it has a max pool size, which means if there are too many tasks for these 10 threads to handle or to process, then it is allowed to create up to 20 threads in total in order to increase the speed at which the task submitted to the ThreadPoolExecutor here is executed, is processed, or are processed. Then there's a keep alive time here, and that is that says something about these idle threads. Let's say it has grown from 10 to 20 threads, that after this keep alive time here, then the ThreadPoolExecutor is allowed to terminate these extra pool threads again. So basically here I have set the keep alive time to 3000, which is, you can see here, 3000 milliseconds, which is 3 seconds. And that means that if a thread pool that is not part of the 10 core pool threads, so if it's an extra thread here, if it has been idle for more than 3 seconds, then it is allowed to terminate itself. The final parameter here to the ThreadPoolExecutor constructor is an array blocking queue, and that is the queue which the tasks submitted to the ThreadPoolExecutor is stored in, and from the outside here they will be stored in this queue, and then these pool threads in here will take the tasks from the queue here one at a time and execute them. Down here below I have another example which also creates a ThreadPoolExecutor, but it does so using the executors class factory method. And so it calls new fixed thread pool, which returns an implementation of the executor interface, but it is in fact a ThreadPoolExecutor instance that is returned with 3 thread pools internally, and which cannot grow beyond those 3. So core pool size and max pool size is set to 3 for both of them. Now let's have a look at the methods of the ExecutorService interface. The first method that we should take a look at is the execute method, which we have already looked at before. The execute method simply takes a runnable implementation and executes it. And as you can see here, that is exactly what is going on in this example here. You have already seen how this works. So these 3 tasks here are implementations of the runnable interface, and they are simply executed, and that is it. And then we shut down the ExecutorService here, and you have already seen how this works. So that is how the execute method works. By the way, here's a small curiosity here. Calling the executor's new fixed thread pool and passing it a number of 1, meaning it should only have 1 thread internal in the pool, is actually the same as calling the method here that is called new single thread executor. It has the same effect. It creates a thread pool with only 1 thread internally. The next method we need to take a look at is the submit method. Now the submit method works similarly to the execute method, but there is a little bit of a difference. You still pass an implementation of the runnable interface as parameter to the submit method, but the submit method returns a future which gives you some information about the status of this task. the future has a method called isDone, and this method can tell you whether the task has been executed or not. In this example here, right after submission, the task is probably, in most cases, not done yet. So we will expect this statement here to print false in the majority of the cases. But it is actually possible that this task was executed before, inside the thread pool, before this thread here progressed to this instruction. But in most cases, it will not be so. The get method of the future interface, the future is an interface, the get method of the future interface returns a result from this task. However, the runnable interface is unable to return any results because the run method returns void. So whatever get returns will be, in this case, will be null. I mean, it will always return null. However, there is one other effect of the get method, and that is that the main thread here, that when it calls get, then it blocks until there is a result available. Now in this case, where the runnable cannot return a result, well then this main thread here is simply blocked until this runnable has been executed, and then it will return, and it will return null because there was no result from the runnable. However, once get returns, the task has been executed, and the isDone method will now return true. So let's try to run this example here and see what happens. This is what we expect. First it prints false up here because the task is not yet executed. Then the task executes, and the main thread here is waiting in the get call until the task has fully executed, and then we print future is done out again, and this time it is true. The next method to look at is a version of the submit method, which takes a callable as parameter instead of a runnable. Callable is an interface that has a single method named call. Now the call method can return an object, whereas the runnable's run method could not, because it returned void. The return type was set to void. So in this case here, we are able to compute a value from our task and return it back to whatever mechanism that calls this callable instance, which in the example above is the thread pool here. Now, if we go back up here, you can see this is another version. It's an overloaded method. Submit is overloaded. So this is another version of the submit method, which takes a callable instead. Now, this version of the method still returns a future. And from this future, we can still ask whether the task has completed executing. However, now we can actually get a result back from the future. And so get still blocks until the task has been fully executed. But now, because call is capable of returning an object, we can actually get this string back from the callable. And now, after we have obtained it here, waiting for the task to execute and then obtain the return value, we print it out here. And then after that, we print whether the task is done or not, and then shut down the executor service. So what is expected to happen is that at this point, the task will not yet be done. Here it blocks until the task is done. Here we print out the result, the string that is returned from the callable you saw down here. And then now the task is done, and now it will print true here. So let's run this example and see what happens. As you can see, false, and the name of the task, the value returned from here, and then true because now the task is actually executed. Let me just spend a little bit of time explaining this mechanism with the future. At the time the task is submitted here to the thread pool, at this time the thread pool creates a future and connects it to this task internally. When the task finishes executing, it can update the future with the status of the execution status of the task and any return value obtained from the task. And so this future is returned immediately to the main thread here before the task is executed by any pool thread. not after. And as the task is executed in here by a thread, then this thread here will update the status of the future so that the thread out here can see whether it is done or not, and also whether also the return value of the task. The next method we are going to have a look at is a method called invokeAny. The invokeAny method of the ExecutorService interface will take a collection of callables, so a collection of tasks, and then it will invoke one of them, or whatever of these tasks is first executed is the result that you will get back. Once one of these tasks is fully executed, any other waiting tasks from this collection here will get cancelled. Now, the reason you might want to use the invokeAny method is, for instance, imagine that you have a service, no, you have a client, you have an application that needs to call some backend to get some information. And instead of calling one server and wait for that server in case that server is busy, well, then maybe you have 3 servers that you can call, and you just want what the result from each of the server will be the same, and you just want the result from whatever server responds the fastest. So basically what you do is you say, okay, call server 1, call server 2, call server 3, and whichever of the servers responds first, that is the result I will use. And you know that the servers will anyways return the same result. You are just calling 3 servers to gain more speed. You want to get the result as fast as possible, so whatever server answers first will give you a higher speed, right? This is something you can do to bring down latency, but only if you really need to bring down latency in your system. Anyways, invokeAny will invoke one of these tasks here and then return the result immediately, and then we print out the result here. And as you can see from this callable down here, the return value will be the name of the thread that executed the callable plus the message that we pass in here. So it will be the name of the thread plus this text here. Let's try to run this example here and see what happens. All right, in this case, the first task to get executed was task 1.3 by pool thread 3. Let's try again. Now you can see same result. Let's try again. Now it changed, right? Now it was task 1.1 that was executed first by pool thread 1. We can try one more time and you will see maybe now it changed back to a 3. The executor interface also has a method named invokeAll. This method also takes a collection of tasks in the form of callable implementations, but it will execute all of the tasks instead of only one of them. This example here shows an example of how to use the invokeAll method. We first create an executor service, create 3 tasks here, put them into a list, and then we pass that list to the invokeAll method. The invokeAll method returns a list of futures, and these futures can be used to check check the status of the tasks that are being executed in here, and also to obtain the result from the tasks, because these are callable, so they can return a result from the execution. So when I have this list of futures, I can now iterate it, and then I can call the methods on each future as I see fit. I can check if the future is done. I can call get here if I want to check or to get the result of the task. Now in this case, I don't check if the future is done. I simply loop through all the futures, call get, and so that means that it waits for the task to complete, then obtain the result. And so when this loop finishes, then all of the tasks will have finished because I have looped through all of the futures connected to the tasks here and waited for each of them to complete. And now let's try to, you can see here we shut down the executor service at the end. Now let's try to run this and see what we get out. Now, as you can see, we get exactly 3 messages printed out, because those are the result returns by the callables. And as you can see, the return value down here is the same as it has been in all the other examples you have seen earlier. A string that is concatenated from the, or which is constructed from the name of the thread executing the task. So the name of the thread concatenated with the message passed into the new callable method, which, as you can see up here, is task 1.1, 1.2, 1.3, and that is what is printed out down here, the name of the thread and this message passed to new callable.